Hello viewers, myself Dr. Srinivas Rao, Associate Professor, Department of Mathematics, Sri Venkateshwara College of Engineering. Today I am going to discuss the topic vector algebra. I am focusing this chapter because it comes under different schemes of lateral entry students. So just I will give the overview of that. So Mat Dip 401, 15 Mat Dip 31 as well as 17 Mat Dip 31. In this scheme, the first scheme, it is a unit wise, so students can answer 60 marks, whereas these two schemes 15 and 17 module wise, students can answer 35 marks. So just I will give you the brief introduction. What are all the topics I am going to cover in this vector algebra? So just the basic concepts: product, algebra, and angle of intersection. So just the basic concepts. Already we studied this scalars and vectors and unit vectors, all these things in high school level as well as plus 2 level. Similarly, the product of two vectors we have dot product as well as cross product, and algebra nothing but just addition and subtraction of two vectors as well as angle of intersection. This is the one more interesting topic as well as a compulsory question in the university examination. Just I'll give the definitions. Vectors or vector. So we know that vector is a physical quantity which has both magnitude as well as direction. So example, if I can give velocity, acceleration, etc. Similarly, scalars. Scalar is a physical quantity which has only magnitude but not direction. So example, I can give mass, volume, etc. So just observe these examples. While in the vector, it has some value, that is magnitude, as well as in the direction, it becomes plus or minus, positive or negative. Whereas in the scalar, that is a mass or volume you take. Mass, for example, it has some weight, so 2 kg or 3 kg. Either you upward or downward, the weight of the object will not decrease or increase. So therefore, these are the examples of scalars, and the velocity, acceleration, force, whatever you take, is the examples of vector. Now, how we will represent a vector? See, consider three-dimension axis, coordinate axis, say x-axis, y-axis, as well as z-axis. So now, if I mark one point P, say P, it has a coordinates x comma y comma z. So this point I can represent in a vector. I can write like this: P is equal to x I cap plus y j cap plus z k cap. So here I cap is a unit vector along x axis, j cap is a unit vector along y axis, whereas k cap is a unit vector along z axis. So any point we can represent in the form of vector. Now, same way, instead of xi, yj, zk, if I take any vector, say a, this can be written like this: a1 I cap plus a2 j cap plus a3 k cap. Nothing but it is a1 unit along x-axis, a2 unit along y-axis, a3 unit along z-axis. Similarly, if I take any other vector, say b, I can write b1 I cap, b2 j cap, b3 k cap. Now the basic definition of unit vector. Unit vector. Let us consider a vector A. A is equal to a1 I cap plus a2 j cap plus a3 k cap. So you take any vector. I want to calculate the unit vector. Unit vector of a vector definition denoted as a cap and is given by unit vector a cap is equal to vector a divided by its magnitude. Magnitude of a denoted by the mod a, and where the formula to calculate magnitude is magnitude of a equals square root of a1 square plus a2 square plus a3 square. So this is, just observe, a1 square nothing but coefficient of I, a2 nothing but coefficient of j, and a3 nothing but coefficient of k. I have to square each term and it is a square root. I will explain with one example. Say let a is equal to say 2i cap minus 2j cap plus 3k cap. So unit vector of a, that is a cap, is equal to, according to the formula, vector a. So that is nothing but 2i minus 2j plus 3k divided by square root of magnitude of a is square root of root a1 square plus a2 square plus a3 square. a1 nothing but 2 square plus a2 nothing but minus 2 whole square plus a3 3 square. So that become vector a 2i minus 2j plus 3k divided by square root of 2 square is 4 plus minus 2 whole square. So minus become plus because it is a square, it become 4 plus 3 square is 9. So that is 9 plus 4 is 13, 13 plus 4 is 17. Finally, a cap is equal to 2i minus 2j plus 3k divided by square root of 70. So this is the way of calculating unit vector. The students, just observe here, in a magnitude of a, it is a square root of a1 square plus a2 square, a3 square. So square for every term. So if it is in the vector, if there is a minus, that minus become plus. So you should carefully observe, because inside the square root no negative comes, especially in the magnitude. Okay, now I'll explain the concept of product of a vector.